Welcome to my presentation, LEAP Simplicity, Laerdal Scenario Design Made Easy. My name is Brian Wallenberg. I'm a simulation specialist at the Perry Center for Clinical Skills and Simulation at the University of South Dakota, Sanford School of Medicine in Sioux Falls, South Dakota. A little bit of information about the Perry Center. We've been in existence since the fall of 2012. We came about through generous donations from the Leona and Harry B. Helmsley Foundation, health systems from our area, along with faculty. Our learners primarily come from the medical school, our residency programs, the School of Nursing, respiratory therapy, pharmacy, occupational therapy, physical therapy, and high school students. Our daily operations require 5 full-time staff and 2 part-time staff. We have roughly 8,000 square feet. This is divided into 2 simulation labs, 10 exam rooms, 2 control rooms, and 2 classrooms. When we started creating our own scenarios, we dug into the software a little deeper and found that it is quite flexible and that we could use it to our advantage. We realized that we were spending a lot of time programming our scenarios and that we had to come up with a more efficient way to make this happen. Similar to an automobile or a camera, LEAP software allows you to run an automatic mode or a manual mode or a combination of both. We all know that learners can take a scenario 1,000 directions. We found that using predefined labeled changes or custom user events, we can make changes faster and not get stuck if the care of the simulator is something we did not expect. Or when a timeout is called, faculty would like the learners to back up a few steps in the scenario and start up again. Oftentimes, using even our own traditionally programmed software, we would have to restart the program and fast forward to where we needed to be and then continue on. Using the scenario programming method that I'm going to show you today will save you time, money, energy, and a lot of headaches, not only for you, but for faculty and students. In LEAP software, manual mode allows us to be more flexible. Consider it a manual with override. Software flexibility is the ability of software to change easily in response to different user and system requirements. Laerdal LLEAP software allows us to be extremely flexible when diving into the inner workings of the software. Other important factors are faculty flexibility and your own SimCenter's flexibility. We all know that the more flexible things are, the smoother things will go. If you've ever operated a mannequin, you've had this feeling before, not enough hands and fingers to go around. Using LEAP Simplicity will help limit that feeling. The decision has to be made for what's best for you and your center. How much time do you have to program, and how detailed does your programming need to be? The typical scenario looks something like this. All these frames are connected to each other. They flow basically in one direction and rarely move backwards. We create pathways and hope that learners follow one of them. Our programming concept is slightly different. We eliminate all the connections and add a go-to or a hub where the previous settings reside. Initially, we weren't sure how we would be received by showing you a new way to use the software, but we want to be clear that we are not altering or changing any of your software package, we're just using it differently. We found that Laerdal has an extremely flexible product. LEAP Scenario Design is a series of frames that each contain mannequin settings. As the learner completes pre-programmed events, the scenario progresses to the next frame. These events can be manufactured, predefined user events, time-lapsed based, or custom user events. Our process of creating scenarios in SimDesigner eliminates manufactured predefined user events. We will continue to use the time-lapse based events and create custom user events. This traditionally programmed scenario has 12 frames. Each of those frames contains different settings for the mannequin. As the learner completes predefined events, the scenario progresses to the next frame, and the mannequin makes the pre-programmed changes that were programmed into that frame. The key thing to remember is that this scenario will never move in reverse. If you want to back up 2 steps, you would need to stop the scenario, restart, and fast forward to where you want to be. If you wanted to program this scenario in such a way that you wanted to move from one frame to any other frame in this scenario at any point in time, it would require 132 connections. I'm going to show you how to eliminate all these connections, making a more flexible scenario so that you can move freely from one frame to another. So how do we go about doing this, you ask? We build the same number of frames, we connect them slightly different, and we add an additional frame called the hub. Similar to the standard approach, each frame is programmed with all the mannequin settings, plus an additional setting that moves all of that information that was previously programmed into the frame to the hub. Those settings will continue to live in the hub and continue sending information to the mannequin until the mannequin operator selects a different frame to send to the hub. When the hub recognizes new information, it applies it to the mannequin. By creating your scenarios in this manner, you decrease the number of connections tenfold. We have 12 frames and one hub versus 12 frames and 132 connections between those 12 frames. Some of the benefits that we've noticed since we started programming our LEAP software in this manner. The time needed for faculty to be trained on software has been greatly diminished. The communication between faculty and the simulation tech is improved with less communication. The ability to move anywhere in the scenario at any time allows for great flexibility. We spend much less time programming our scenarios. We've created templates that also help with efficiency. We were able to increase our traffic in the center by spending less time with operations, and we spend less time resetting and rebooting simulation is expensive, it is time consuming, and requires a lot of manpower. We need to do whatever we can to make it easy. This tutorial explains an innovative and easy to program technique that allows for creating high-fidelity, flexible, semi-automatic simulation scenarios. The hub concept is applicable to any high-fidelity simulation, but the implementation of the concepts depends on the particular features of each individual brand of simulator. This brochure covers the hub concept and its implementation using Laerdal LLEAP software. This concept does not alter the original software code. This concept was developed and implemented by Dr. Val Kosmenko and Brian Wallenberg, both employees of the Perry Center for Clinical Skills and Simulation, the University of South Dakota, Sanford School of Medicine. This tutorial is free to use and free to redistribute as whole with the appropriate recognition of the authors and the University of South Dakota. No part of the tutorial can be altered, edited, or otherwise used to create derivative work without written permission from the copyright holder. Most high-fidelity simulators have built-in scenario players. A typical scenario is a cascade of the interconnected physiological states. When a specific condition is met, the scenario transitions to the designated state. Even though this principle seems simple and easy to use, it often produces scenarios that lack flexibility. For instance, in the given example, it is not possible to advance the scenario from state 10 to state 3. We're going to change the structure of the scenario in such a way that it will allow to transition from any frame to any other frame in the scenario at the operator's discretion. First, we remove all conditional links that connect the frames within the scenario and let the operator decide to what state the scenario needs to transition. Second, we develop a mechanism that tells the scenario to what frame the operator wants the scenario to transition. If we try to achieve this goal with interconnecting all the states in the scenario, it would require creating too many connections or transitions and would make the scenario impractical. Instead of communicating with each other, we make all the states in the scenario communicate only with one state called the hub, as you'll see in the next picture. With this approach, the scenario always resides in the hub. When a command to transition to a specific state is received, the scenario advances to the designated state, performs changes of the physiological parameters programmed in that state, and then returns to the hub. Using the hub concept allows for seamless transition from any state to any other state in the scenario. Also, when the hub scenario template is used, programming a new scenario requires only filling in the states or frames with the corresponding vital signs, significantly reducing the programming time. This is an example of what your SimDesigner software will look like when programming with the hub. This is what the software will look like when running a simulation. To navigate between states, the operator needs just to simply click the name of the state in the left upper quadrant of the screen. We're going to go through step by step developing a hub scenario. Step 1, sketch out the scenario on the piece of paper, count the states, and give them short names. Pencil into the states what physiological changes need to be programmed, and then launch SimDesigner, select a title, and mannequin for your scenario. Select the Click to Add New State box and a new state will open. Click inside of the New State box and title it Hub and select OK. Continue selecting Click to Add New State box until you have the desired number of states that you previously penciled. We will program the desired physiological changes later in the sequence. Select each of the states separately and give them each a new name. The name can either be a numbered state or a key descriptive word that is identifiable with the major physiological changes that will be present in the state. Now we'll begin the process of connecting the states. Connect each state to the hub by clicking and dragging the chain link from each state to the hub state. Once you've connected each state, including the initial state, to the hub, you'll be left with a perforated box titled Drop Event Here. Select the box. A new box with programmable fields will appear. In the Custom Description area, type the word Hub. The next field is Triggered Event. Select Browse and scroll to the bottom of the options list. Choose Time in State, select the down arrow and choose is less than or equal to, and then add 1/100th of a second. Repeat the last step until you have all remaining states connected to the hub. The next step will be to connect the hub back to each state. In order to do this, click and drag the chain link below the hub state and drag it to state 1. Then repeat the same step for all additional states. Once you've made all the connections, you'll be left with a perforated box titled Drop Event Here. In similar fashion as before, select the Drop Event Here box. Important, whatever you title this box will be the title of the trigger that will appear in the instructor software while running the simulation. It is important that you have a descriptive 1 or 2 word title. For the sake of keeping things simple, I will give the state number as the custom description. To define the trigger, select Browse. A new window will appear. In the lower left-hand corner of the new window, there's an option to choose New Event. Select it. In the event editor, type the event name, confirm that Normal Event is already present in the event type, select the drop-down arrow and select Show Count, Always Visible. Your new custom event is now created. Repeat this step until all perforated boxes have a title and have been programmed correctly. Be sure to connect the initial state box with the hub just like you did with all the other states. This is an easy step to forget. The scenario has all frames and the hub is in place, as well as the mechanisms to advance the scenario to any frame at any moment in the scenario. Since no physiologic changes have been programmed into the frames yet, you may want to save the scenario at this point and use it as a template for future scenarios. Program all the physiologic changes into each state and your scenario is ready to use. You have finished your first hub scenario. When you open the hub scenario within the LEAP instructor application, your screen will look like it is depicted here. In the upper left quadrant of the screen, you can see the list with all your custom learner events. Clicking any of them will advance the scenario to the corresponding frame. It is very simple to navigate back and forth in any direction. To efficiently make all physiologic changes in the scenario with just one click of the mouse. At this point, I'll log into the LEAP software and do a demonstration to help alleviate some of the questions. All right, let's get started. Open up the LEAP Simulation Suite and navigate to the SimDesigner. Once in the SimDesigner, we'll create a new scenario. Once you have that created, we'll have to give it a name. Select any additional parameters that you would like to see with this scenario. Choose the mannequin type, if you would like SPO2 or not, and select OK. This is where we create the number of states that are needed for our scenario. So if you had your states penciled out on a piece of paper, add enough states that matches your design plus 1 that we'll create as the hub. Once you've created the hub, drag the chain link from below each state to your state that will become the hub. Click inside of the state itself and rename each state a descriptive name that you'll be able to determine while running the scenario what will happen inside of that state. Be sure to include hub as the first one, as I did in the center, and then make your way around to all other states, giving them that descriptive name. We'll include the physiological changes in each of these states later in the build. Once you've connected each state, including the initial state, to the hub, you'll be left with a perforated box titled Drop Event Here. Select the box. A new box with programmable fields will appear. In the custom description area, type the word hub. Next field is triggering event. Select Browse and scroll to the bottom of the options list and choose Time in State. Select the down arrow and choose is less than or equal to and add 0.01 seconds. Repeat this step until you have all remaining states connected to the hub. The next step will be to connect the hub back to each of the states. In order to do this, click and drag the chain link below the hub state and drag it to state 1, and then repeat the same step for all additional states. In similar fashion as before, select the Drop Event Here box and give the state a name. Whatever you title this box will be the title of the trigger that will appear in the instructor software while running the simulation. It is important that you have a descriptive 1 or 2 word title. Once you have the title entered, select Browse. In the lower left corner, there is New Event. Select it. In the event name, use the exact same name that you used to title the state. Enter a default category for the event. Select My Events and select OK. Select OK one more time. Confirm that everything is correct and select OK again. Your custom event is now created. Repeat these steps until all perforated boxes have a title and have been programmed correctly. The scenario now has all frames and the hub in place, as well as the mechanisms to advance the scenario to any frame at any moment in the scenario. Since no physiologic changes have been programmed yet, you may want to save the scenario at this point and use it as a template for future scenarios. Otherwise, we will go ahead and program all physiological changes into each state, and your scenario will be ready to use. once all the physiological changes have been programmed, select Save and confirm the name of your new scenario. Now we will return to the instructor mode and test our scenario. You will see all of our pre-programmed states in the left-hand pane. Each have the descriptive name that you applied, and each hold all of the physiological changes that you want in each of those states. We can select any state in any order, and those physiological changes will be applied to the mannequin and the patient monitor. Congratulations, you have completed your scenario.